Good morning, students. I, Shalini Kajotra, PGT Computer Science of KV Kathua, want to explain about sorting technique. Basically, sorting means to arrange the element in a particular order, mean in ascending or descending order. We take the example of as we are standing in front of morning assembly. All the students are in a ascending order. So, but in computer terms, sorting in computer terms refers to arranging element in specific order, ascending or descending. Now, the next is type of sorting. There are lots of sorting techniques available, but we will discuss bubble sort, insertion sort, but in we have another method, that is the selection sort, but we will not discuss in Python about this selection sort. So we will discuss one by one. That is, first we will discuss our bubble sort. The basic idea of bubble sort is to compare two adjoining values and exchange them. If they are not in proper order, bubble sort sometimes refers to as sinking sort is a simple sorting algorithm that repeatedly steps through the list, compare the adjacent element and swap them if they are in wrong order. The pass through the list is repeated until the list is sort. Means in case of bubble sort, we compare the two adjoining elements, and then if they are not in proper order, they will swap. Then again next two elements and then swap until the list should be sorted. So that's why this is called as a bubble. Now we will discuss with the help of an example. Here I have take a list of 5 elements with 5, 1, 4, 2, 8. We will here first two elements 5 and 1 will compare. Where 5 is greater than 1, then swapping will be done. Now in next case 5 and 4. 5 is greater than 4, again swapping will be done. Now in the next case, you see in this diagram 1, 4, 5 and 2. Now the comparison between 5 and 2. 2 is again smaller than 5, then swapping will be done. Now if we compare with the last two elements 5 and 8. Now 8 is greater than 5, so 5 is smaller than 8, then no swapping will be done. Now we have a list of 1, 4, 2, 5, 8. In first pass, the largest element is fixed at the end position, and this is called as the first pass. Now we will move to the next pass, second pass. 1, 4, 2, 5, 8. Now we will see or compare with 1 and 4. Here 1 is smaller than 4, no swapping will be done. Then 4 and 2. As you see, 4 is smaller than 4 is greater than 2, so swapping will be done. Then we compare 4 with 5. Now in this case 5 is greater than 4, so 5 there will be no swapping. Now in second pass, remember the second largest element is fixed. So we can see in this list 5 and 8 is fixed. Now in third pass, we compare 1 and 2. 1 is smaller than 2, then there is no swapping will be done. 2 and 4, there is again no swapping will be done. Now you see the third largest element is fixed. Now if we compare 1 with the 2, 2 is again greater than 1. So we have a list of sorted elements. In the last we will get the list of sorted elements, that is 1, 2, 5, 4, 5, 8. Now we will discuss how this process of swapping will be done in Python program with the help of Python program. We have a Python program in which we take a list. I have taken a list 15, 6, 3, 22, 3, 52 and 2. First of all, we have to print the original list. Now, we calculate the length of the list. Here I have used two nested loop. I in range of n means I have to take all elements, and j in range from 0 to n minus 1 minus 1. It means that here in this case the largest element, with the help of this loop, the largest element will be fixed. Now we have to compare with the two elements, the first a of j and a of j plus 1. If a of j is greater, when the first element is greater than the next element, then the swapping will be done, and this whole process carried on till the sorting will be done. And after this process going on, two nested loop will be going on, then we will get the list of sorted elements. Now next, our insertion sort. The basic technology deals with the insertion sort is that builds a sorted list of element at a time from the sorted list by inserting the element in a correct position in the sorted list. Means there is no more cases. With the help of a single algorithm, we can sort the elements. Insertion sort is simple sorting algorithm that builds the final sorted array element at a time, that is adaptive, efficient for data set that are already substantially sorted. The time complexity is O k of n when each element is input is no more than k places away from its sorted list. It is basically a technology which we are using in sorting, where a single element, if we take a single element, it will take its proper position with the help of insertion sort. Now see how the process will be going on with the help of a particular diagram. I have a list of 6 elements: 85, 12, 59, 45, 72, 51. Here we are comparing. Assume 87, 85 is the sorted list of first element. Now we compare 85 is greater than 12, shift to the right. Means 85 is shifted to the right and 12. So 12 will be insert in that place, in a particular place. Now next we have to compare 85 with 59. 59, as you know, is smaller than the 85, and 59 will be in the, then again 59 will be compared with the 12, but 59 is greater than 12, so I have a list of 12, 59 and 85, 45, 72 and 51. Now we take the next 45. Comparison between 85 and 45. Then 85 is lower than 45 is lower than 85. It will be at the position 12, 59. But again 59 and 45 will be compared, through which we get that 45 is lower than 59. So we have a list of 12, 40, then again swapping will be done. We have a list of 12, 45, 59 and 85 will be in a list. Now again we compare 72 with the whole list. We compare it 85 with 72, and 72 will be again compare with the previous list, but 72 is greater than the previous list, so it will place its position at the fourth element. Now the last element 51. If we compare the 51 with 85, 51 is lower than 85. But 51 again compare with 72. Again swapping will be done. Then again 51 is compared with 59. Now again swapping will be done. Now again if we compare 51 with 45, but 51 is greater than 45, now it will placed. Now you see at the end I have got my list of sorted elements. Now this is how we do insertion sort, but how this insertion sort will be implemented in Python program. We see the Python program. Now again we have a list of sorted elements, we have a list of unsorted elements. Then we print the list. Now calculate the length of the list. Here we do a loop for I in range 1 to, remember this, we are start from 1 to L. We take a key, as we have taken a key variable as list of I, and j is I minus 1, means j is less than I, because I start with the 1. Now we compare if j greater than equal to 1 and key less than a of j. Now swapping will be done and j is j minus 1. Here in this case, every element when going back, it compare with the previous element, again compare with the previous element, because j is j minus 1. This way we are comparing. If j is not less than equal to j plus 1 is not less than, then else condition j plus 1 equal to key, and at the end we get the sorted list. This is all about our insertion sort. Now we have the next is how to count the number of iteration in a sorted list. Here we have to do with the help of our program. Counting sort array and max value. M is equal to max plus 1, count 0 into M. For A in array 1, count occurrence is equal to count plus 1. I is equal to 0. A in range M. C in range of count of A. And array of I is A, and I is equal to I plus 1. Return A and return count. Now this is, here we are passing my array and print the number of iteration. This is about how to count the number of iteration in a Python program. This is all about our sorting techniques, and thank you for watching.